So here's how you find the nth term for a quadratic number pattern. So a quadratic number pattern is just a pattern that has a quadratic nth term, like this one or this one. A quadratic is just something with a squared in it, like that, and no cube, no power higher than squared. So that's what a quadratic number pattern is, and another way of saying number pattern, by the way, is sequence or series, all means the same stuff. So here's the example. We're going to find the nth term for this sequence that begins 4, 13, 26, 43. And the first thing we've got to do is check that it is in fact a quadratic number pattern. So you write your sequence out and you look at the differences and you look at the differences between the differences. So let's just quickly show you what I mean by that. The difference between 4 and 13 is 9, the difference between 13 and 26 is 13, and so on and so forth. And the difference between these differences is 4. Basically you keep getting 4. You've got a common difference between the differences, and that tells you you have a quadratic number pattern. So that not only tells you've got a quadratic number pattern, by the way, it also tells you how many n squareds there are in your nth term for this pattern. How do I know that? Well, there is another video where I explain that this number here is always twice the number of n squared in your pattern. So basically this 4 tells you that you've got 2 n squareds in the nth term for this number pattern, which we've just checked also is a quadratic number pattern. So what do we do next? After you're doing this, you draw up this table. This table basically says that n, which represents where you are in a number pattern. So I'm going to write n is 1, 2, 3, 4, and I'm going to write the first number of my pattern here, the second number underneath n is 2, the third number when n is 4, and so 3, and the fourth number when n is 4. So just so you know, when we're drawing up this table, we don't know this bit yet. We're going to arrive at this in a minute. And so all we've got is n is 1, 2, 3, 4. We've got the number pattern itself, and because of this, which told us that we've got 2n squareds in our pattern, we write 2n squared. And then now I'm going to write the 2n squared pattern underneath n is 1, 2, 3, and 4. I'm going to write the first 4 terms of the 2n squared pattern. So that's really easy to do. You write n, when n is 1, you got 2 times 1 squared, which is 2. When n is 2, you got 2 squared times 2, which is 8. So underneath 2 you put 8, and you keep doing that. So you got 2, 8, 18, 32 is the 2n squared pattern. And you take this pattern away from our original pattern. So 4 take away 2 is 2, 13 take away 8 is 5, and keep going like that, and you get another number pattern. So you do this pattern, take away this pattern, which gives you this pattern, 2, 5, 8, 11. And then you find the nth term for this pattern. So this is a very basic pattern which I've explained how to get before, but very briefly this is how you do it. You look at the differences, and I can see, it's going up by 3. 2 plus 3 is 5, 5 plus 3 is 8, etc. So it's going up by 3, which means it's like the 3 times table. And when you've got the 3 times table, you write 3n. But it's not quite the 3 times table, is it? The 3 times table begins with 3, and this begins with 2. So this is 1 behind the 3 times table. The next term should have been 6 if it was a 3 times table, but it's 5. Again, 1 behind the 3 times table. So this is the 3 times table, take away 1. So you write 3n minus 1. 3n means 3 times table. 3n minus 1 means 3 times table minus 1. So the nth term for this is 3n minus 1. The nth term for this is 2n squared. And now we knew we've got from here, we got this by doing the original pattern, take away this pattern to get this. So the reverse should be this pattern plus this pattern makes the original pattern. So this nth term plus this nth term makes the original nth term. So 2n squared plus 3n minus 1 makes the original nth term. 2n squared plus 3n minus 1. And we can check that this is right simply by putting n equals 1 into this. So 2 times 1 squared is 2, plus 3 times 1 is 3, minus 1. So 2 plus 3 minus 1 is 4. Good, that worked. Let's try one more. N is 2, so 2 squared is 4, times 2 is 8, plus 3 times 2, which is 6. So 8 plus 6 minus 1, yes, that's 13. So basically you can see it's working. So that is the nth term of our pattern that we had originally.